Hello, welcome to a closer look at SolidWorks Sustainability 2011. A product's greenness is a factor that more and more consumers are paying attention to. As this influence grows in the market, many companies see this as a new and unfamiliar challenge to their business. Sustainable design is an important strategy that companies can use to reduce the environmental impact of the products they produce. But up until now, how to do sustainable design has been a mystery to these companies. SolidWorks Sustainability has been created so that sustainable design becomes easy to understand and effortless to employ. Features such as its dashboard, customized reports, and find similar materials allow users to easily improve their designs and communicate their accomplishments in a compelling way. This is seen as so important that SolidWorks has included some of these sustainable design features in every seat of SolidWorks 2011. This presentation will cover those features and those provided in the full SolidWorks Sustainability product. SolidWorks Sustainability will categorize sustainable design by taking a life cycle assessment of our components. By understanding the raw material extraction, transportation, material processing, part manufacturing, assembly, product use, and end of life, we will know the carbon footprint, total energy, air acidification, and water eutrophication of each of our components. And the tool set provided in SolidWorks Sustainability can help us improve in all four of these categories. Let's take a look. SolidWorks Sustainability is an incredibly powerful tool inside SolidWorks that enables us to gain insight into our design and its environmental impact. More importantly, it provides us with a very efficient way of evaluating design changes to minimize the impact of our design on the environment. It's also advantageous to do this early in the design cycle, as this has a larger impact on reducing time and cost. In this design example, we're focusing on a personal humidifier, and we want to see if we can implement changes to improve the environmental impact. Compared to Sustainability Express, there are additional features in the full product. As before, you can specify region of manufacture and consumption, but in addition to that, you can also specify the mode of transportation. We can also account for the energy consumed over the life of the product. We'll talk more about the breakdown in the environmental impact factors shortly. The most important thing we want to do is set our baseline of the initial design so we can determine if changes improve or worsen the environmental impact. A key element of sustainability is the level of integration we have inside SolidWorks. We can use assembly visualization to look at the aspects such as mass, density, total weight, and so on. But we can also support the sustainability characteristics such as material class or specific material. In our case, we are more interested in evaluating the carbon footprint and trying to minimize that in our design. We can see that we have a sort order that highlights which components have the largest carbon footprint. We can use the sliders to zero in or highlight particular parts of interest or concern. Additionally, we can grab the rollback bar to filter the components displayed, so it's an incredibly flexible interface. When we select a part in the tree, we can then adjust its environmental properties on the fly. Perhaps we want the heater holder, which is a stamped component, manufactured locally. After making the change, the environmental factors update, showing a slight improvement. Focusing on the two components with the highest carbon footprint, we can utilize the Find Similar tool to identify alternative materials that still meet our needs but reduce the environmental impact. In this instance, we want to focus on alternative plastics and anything that is less dense. The structural strength is not the most critical aspect in our casing. Since this is a high temperature environment, we want to look at plastics with less thermal conductivity. SolidWorks Sustainability then sorts through the material database and filters down to a selection that meets our criterion. We can further drill down by selecting a few candidates from the list and then click on each in turn to see if it improves the environmental impact. So you can see that the polypropylenes have the biggest improvement over the polyethyl imide we started out with. Of these, the homopolymer has the least environmental impact, so we'll accept that one. We will see that the assembly visualization updated to reflect the material change. We could do the same steps for the underbase as well, but we are going to go and directly modify the material to the polypropylene homopolymer. It's valuable to use the Find Similar tool, as the manufacturing method, volume of part, and other factors govern the environmental impact and which material is best. Now, it's always important to communicate your design information to others in the company. With sustainability, we have a fantastic report that automatically captures the result of our investigation, starting with our initial design and then highlighting the improvements achieved through our changes. With the updated model at the start, notice that the weight is about 522 grams. We have the information on manufacturing location and usage, as well as the breakdown of the environmental impact factors. And then we have a breakdown on which parts are the best and worst environmental impact contributors. It shows the tank, top cover, and cover are the worst contributors, whereas the switch and other smaller items like the heater holder and stay have the least impact. The image on the next page reinforces this by showing the parts that are good and bad using red, yellow, and green. Then we have the initial design, where you can see we started out with a weight of 606 grams, so we've reduced the weight by nearly 15% in conjunction with reducing the environmental impact. And then we have our environmental impact comparison graphs relative to the initial design. This report is saved in the same directory as the assembly, so it's easy to locate and access. As changes we make will be propagated to the report with a single button click. One of the great benefits of SolidWorks Sustainability is that it can work in conjunction with our tools such as simulation. In this instance, we're focusing on the water tank, and we want to make sure that it can withstand the loading due to having water in the tank, as well as something sitting on the top. Since this is a personal humidifier, it's quite probable that someone might pile books on top. So let's update the environmental impact properties. And we can set these properties as our baseline. So we can have a force on the tank representing the 5 kilogram load from the books, as well as a pressure load inside the tank acting as the water. Ideally, we want a factor of safety greater than 2. In the initial design, you can see that we have a factor of safety of 2.46. So what we want to investigate is look for materials that reduce the environmental impact that are not detrimental to the strength requirements of the design. To do this, we'll use the Find Similar tool again to identify other plastics of similar density but with higher strength. We can see a filtered list, which again we can reduce to some key candidates by selecting them. If we scroll across, we can look at the tensile strength, and it's apparent that the polypropylenes are good candidates with much higher tensile strengths. So checking the environmental impact reaffirms this. The homopolymer is again the best option for environmental impact, so we accept that and we apply it to the model. Clicking on the Set Materials button, we see that our environmental impact has been updated, and if we go to the simulation study again and rerun it, we can verify that the factor of safety meets our requirements. We can see that it's improved and that the factor of safety is up to 5.2 now. What this really means is that we've reduced our environmental impact, but we've made the part significantly stronger in the process. We don't want the part over design, so we can reduce the wall thickness to remove material and get back closer to the factor of safety goal. Removing additional material further reduces the environmental impact. Click on Run again to update it for the reduced thickness. And we can now see that the factor of safety is around 2.1. By using sustainability in conjunction with simulation, we've not only been able to reduce our impact on the environment, but that we still meet our structural requirements and that the design still meets our needs. Switching back to the assembly, it updates to reflect the changes we made at the part level. So sustainability is a great tool to identify what impact our design will have on the environment, but more importantly, it allows us to evaluate changes to make better design choices, all within the SolidWorks environment. Thank you for listening.